Hello, everybody. People are joining right now, so we'll wait about a minute until everybody joined, and then we will start very soon. If you have any questions, there's a Q&A module at the bottom where you can ask questions. Please ask questions at any point in time, and we will see when we can answer them, but you can type in your questions there. Usually the first question is, will the meeting be recorded? Yes, we are recording it. But if there are any other open questions, there's a Q&A button, or if you have a different language, it might be called a little bit different with 2 speak bubbles at the bottom.
And we'll also make sure that when you have so many questions that we can't answer them all of them, right? There's a Q&A after today's presentation, essentially. And if you have so many questions we can't answer them, we will send you a follow-up with all the answers of all the questions that you have. So no worries. I'm opening up.
Good. I think most people joined.
Okay.
I will hand over to Michael.
Cool. Thanks. Yeah, thanks, Peter, for having me. We want to talk about essentially, generative AI in the Datavault field with Datavault Builder and Flow.BI. And yeah, let me just get started. So it's all about AI-powered Datavault modeling, essentially. Who am I? Just a safe harbor statement here. Who am I? My name is Michael Olschimke. I'm essentially the co-founder of Flow.BI. People know me from the Datavault trainings, essentially, that I've done over the years now, maybe from consulting engagements with Datavault. Peter, we know us from years ago at the conference. I just double-checked it with you because I wasn't 100% sure, but from a conference in the US with Dan back then, should be more than 10 years, I believe, that we know each other. And you always had Datavault Builder, and we had lots of chats about it and lots of talks about it. But Peter, you want to present yourself briefly? Or?
So my name is Petr Beles. I'm working for Datavault Builder really now for 14 years now. We're building this product now for more than 10 years. And my role is today more in pre and post sales. So I'm doing concepts. I'm showing how the tool can be used. And I'm really lucky to be able to do this kind of webinars like we have today with Michael to show how we integrate with other products, how we can consume data models, in that case, from Flow.BI and use it to automate the data vault in Datavault Builder.
Cool. And so we'll see what you do with the model from Flow.BI, essentially. Now, what's Flow.BI? Because, some people are curious, I believe. So the thing is this. Just to be brief, Flow.BI is a generative AI that defines the raw data vault. And the keyword here is defining it. So it defines the raw data vault, including all the hubs, the links, the satellites, including business keys for the hubs, satellites, including security, privacy, rate of change splits, specialty types, effective satellites, non-historized links, reference data, and so on. The thing is, it's data-driven. So it looks at your data and derives the raw data vault that's required to capture all your data, essentially. It's not a LLM approach where it might know where an LLM might know how a hub for customers looks like, but doesn't know how if you have customer data inside your data set, right? So Flow.BI is different. It really looks, it's data-driven. It looks at your data and derives a data vault model for your actual data. And it integrates its existing database automation tools like Datavault Builder. So we don't create or create table statements or the insert into statements for your data warehouse, the physical model as we call it. We only quote unquote generate the logical model. We only define what hubs, links, satellites you need to capture all your data, essentially. That's it. And then we hand it over as metadata to Datavault Builder, and Datavault Builder then generates the statements. Flow.BI generates both the model definition, like which hubs, links, satellites do you need, what are the business keys to be used, what are the attributes, satellite split, and so on, but also the load definitions. From where do you load a business key in the source into the target hub for the business key? From where is a attribute in the satellite loaded from which source systems, essentially? So both the movement and the structure of your models is being populated. So what's the challenge? The problem is, and you all know this from studies or from previous work, that there's a widening gap between, first of all, the volume of the data volume that we have to process is increasing exponentially, right? And with the data volume, there's also some research, not much, but there's also some research that defines or found out more or less that also the data shape that we have to process is also increasing exponentially. Just think about this. You have more and more tables to be processed, more and more columns, more and more structures, JSON structures, and so on. All these different structures pop up now. We have to process it in our database solution essentially. And so that's number one. So there's an exponential increase in both data volume and data shape. And then the question becomes, who should do all this? Yes, there are some tools like Datavault Builder, but we have to analyze the source systems. We have to come up with the target model, let's say Datavault, and we have to essentially set the metadata for Datavault Builder to be able to process it. And that must be done by people. But where should these people come from, right? There's a shortage in people because there's only a number of training places, let's say universities, where data scientists get a training and graduate from, and these universities are limited in number. They have only a limited number in seats where they can train people. And not every student will become a data scientist, right? There's also pilots and dentists and doctors and so on, right? So in my opinion, first of all, there's a widening gap between more and more data to be processed and only a linear increase of more data scientists who can actually do the job, even with all the tools. And yeah, we believe that AI is the only solution to deal with this gap, this widening gap over time. So how do we do it in the past or until today, let's say? We have tools like Datavault Builder where we can generate the code, but still you have to set up the metadata for these tools. So you have to identify the data sources for your data platform. Where should the data come from for your reporting solutions? You have to analyze and profile your source data to identify, let's say, what are the business keys to be used, how are the structures in the model, and so on. You have to come up with an integrated enterprise data model, for example, Data Vault, for your source data. What are the hubs to be used, links to be used, the satellites to be used, what are the business keys, and so on. And then you also want to test the model, right? Are there any inconsistencies when you would load the data the way you would like to do it? When you capture the data this way, do you really capture all data without any data inconsistencies, essentially? And then you have to set up the metadata according to Datavault Builder. So yeah, you have to know the target tool as well, where you want to essentially generate your code, and set up the metadata accordingly, essentially. So your tool, your experts must know the source system to be able to analyze it, the data methodology or some alternative. I don't know many. And then the target tool, right, where they should enter the metadata to. And the idea now of Flow.BI is that Flow is a generative AI, a foundational model essentially, that does exactly those jobs, those tasks. It looks at your data sets, analyzes it, profiles it. It knows Data Vault because we've built a pattern in there. And then it knows the target tool because Datavault Builder consumes the metadata from us and inserts them into their tool essentially. So it just fills the spot essentially where we have typically a shortage of people who know Data Vault at all, right? Who know how to analyze source systems and so on. And it's essentially a highly parallelized application. So we do this instead of over the years to ingest thousands of tables. We can ingest thousands of tables overnight, essentially, or in hours. So yeah, Flow.BI is a Gen AI approach or artificial intelligence. That looks at your data, comes with a data model, and then plugs it into your tool of choice. It's designed by me, so the whole design came from me. I thought about this for years. And the backstory, essentially, of Flow.BI is quite simple. Years ago, when I started with Data Vault in 2012, some people, not many, but some people knew that I was essentially doing a lot of research in data mining, artificial intelligence, back in Silicon Valley, where I was a graduate student, essentially at Santa Clara University. So in my research, we did distribute neural networks on MPP clusters to classify unstructured data sets. That became handy later, let's say. But so people knew it, and not many, but a few people. I believe Peter knew it as well. But some people came to me and said, "Can't we just generate maybe some part of the data model using AI? Maybe the business key identification, maybe part of the model, the definition of the hubs, and so on." And I always ignored this back in 2012 or something, because I was still learning the data patterns. Right, 2012, 2015, the book came out, so that was about the time. Ignored those questions. I didn't have an answer, to be honest. And then 5-6 years ago, it struck me again. So somebody was asking me the same question more or less, and then I started I started thinking about this, right? And took me a couple of years just to think about the solution, how you would build this. Once I had a general idea how you could build this, I then essentially called up some friends. We did some research. After 1 year or 2 years, I had this big bang moment here that you have right now, where I saw this galaxy and I knew we had the solution, essentially how to derive a raw data vault from actual data. And then we started building the product Flow.BI. That's the essentially the full story of Flow.BI, how it came up. All under the hood, under radar, not in the garage, but it was essentially in the under the radar essentially. So I never talked about it, and but I already had the solution already, so it was really cool. So yeah, and the patterns how we derive the data vault. The design of the application comes from me. I haven't built this by myself, but the rules how we set up the raw data vault, those come from me, and I have built those. So that's the idea. You know, database automation. Essentially, nowadays I don't know any project these days where projects build the data vault manually. I only know a few projects where they have built their own generator. Most people use a off-the-shelf product like Datavault Builder essentially to generate the data warehouse. That's the common practice these days. You don't want to build a manual data vault these days. It's too many entities, too many shape to be processed essentially, right? Too many complicated patterns and so on. And these tools, they come with predefined templates, how the target entities should be generated. How does a hub look like on Snowflake or on Synapse or on Oracle and so on, right? How's the structure of a hub, of a link, of a satellite and so on? This physical structure is defined in templates. But then they use metadata. We call this also metadata-driven automation. They use metadata to define what hubs should exist, what links should exist, what are the satellites to be generated, and so on. And the combination of both the metadata and the templates, that produces the physical model, the create table statements and the insert statements for your data platform. That's the basic idea, and that's done by a code generator inside the tool, essentially. The templates are one-time setup, so either they come from the vendor or you sometimes can set them up, you can modify them, but it's essentially done once and done, essentially. But who sets up the metadata? That's a big question, essentially. Because for that, you have to analyze the system. And what Flow.BI does is it generates what we call a logical model, essentially just the definition of the hubs, links, satellites to be produced, all the attributes to be used, the satellite splits, the business keys to be used, and so on. And this logical model is provided then as metadata to Datavault Builder, essentially via a SQL interface, and I can show it to you. We hand it over to Datavault Builder, and they produce essentially the physical model. It's just as if Flow.BI is a teammate in your team, hacks in the metadata in the Datavault Builder, and they generate then the physical model, essentially. That's the basic idea. What are the features? The idea is, well, my initial design challenge was quite simple. I know these days, or a year ago something, people believe that you could only build a data vault manually. So you could only make an artificial intelligence could only assist the data model, essentially, give you some recommendations and you make the final call. But my design principle was, what if it is possible to build a platform where you could just attach data sets via JDBC or just attach data sets, let's say via JDBC drivers or some other means. You just attach the data sets and the system will automatically look at your data, identify the concepts, derive the target model from it, and essentially deploy it. What if you don't have to do anything? Just attach the data and you're done more or less. Yeah, and that's what we built essentially. So the AI takes the lead. The AI will generate everything, but we made sure that we can influence the system, influence the results in many ways, right? But yeah, the idea is just connect to the data source. Any JDBC driver will work eventually. We have to support them though. So you can't just upload a JDBC driver and it works from itself. We have to essentially set up some test case for regression testing, build some wrapper, not much magic to be honest, but just to simplify the metadata extraction, data extraction, and then test everything essentially. And so we have to build these JDBC drivers step by step. At the moment, we support Snowflake, we support Postgres and derivatives like Yuga Bytes or Cetus, AWS, Aurora, Postgres. We support Athena for data lakes. We support Apache Drill for data lakes and SQL Server and derivatives like SQL Server, Synapse, Fabric as a data source, right, to analyze your data sets. and then again hand it over to Datavault Builder, and then it depends on Datavault Builder what platforms they support in the target, where you can have your final data platform essentially. We generate the metadata, the logical model for the enterprise data layer, essentially a data vault that spans. We don't produce a data vault that's only for one single source, right? We produce a data vault, raw data vault model that spans across all your data sources. It's an integrated enterprise data model, as I used to teach it for years, right? It's the hub integrates across systems essentially. So it's not one model per source; it's a model across all source systems. Flow.BI identifies the concepts like customers, products, customers purchase products. Inside your data sources, you can influence this to a good extent, and then it decides on the specific data entities, hub sync satellites, identifies the business keys, and so on. Flow.BI is an enterprise tool, so you can customize everything, or at least most aspects, the relevant aspects, let's say, including the generation of the logical model. So we could even, if you, let's say there's a a concept customer with a business key identified to be the customer number. Let's say that. For us as Datavault specialists, that means there should be a hub customer for your customer concept. There should be a business key customer number inside the hub, and there should be an effectivity satellite with a deletion timeline. Those elements we produce essentially when we're producing the logic model, but we can modify this. So if you don't agree with this approach, if you need some other satellite or something, we can talk about that. So it's all essentially customizable. We also, because I was dealing with some nerds over the years, and another story is we were developing this for years, right, under the radar, and but then last year you saw all the news with these Gen AIs like ChatGPT, for example. And then I said to the team, we have to publish this because we have to go market essentially, because the market is ready now. We have to get there essentially, and that's why we came a bit early, but that's what it is. So, and we had to stop some developments essentially. But what we haven't stopped by stopping that means we package a good MVP, minimum viable product, and that's what we get to the market at the moment. What's included is a natural language generator. So I said, well, I would like to have a documented raw data vault, right, with NLD documents, comments, and attribute comments. So there's an NLG generator that has been designed essentially for documenting data models, where you have loading procedures, where you have NLDs, and so on. And it integrates with Datavault Builder. Datavault Builder generates a physical model essentially. What are the advantages? There's a couple of advantages. First of all, it reduces the technical development effort. You don't have to analyze the source system anymore. It's done by the AI. You don't have to know maybe the and you as an expert, you can focus really on what really matters for the business. That's the business logic, the business value, producing the dashboards, the reports, implementing the business rules in the business vault, and so on. So Flow.BI generates everything including the raw data vault, at least in metadata for that, and you can focus really on everything after that in the business vault, information mart, in the dashboard layer, in the presentation layer. The delivery process becomes more effective, faster, more cost effective, which essentially means quite simple. Think about this. When you have, let's say, 50 tables to be produced, 50 source tables to be derived or to be ingested into a raw data vault, maybe it takes you 1 or 2 or 3 sprints. But what about 1,000 tables? What about 10,000 tables, right? Again, the data set will grow. So it's just a matter of time when we're dealing with these numbers. That takes years sometimes. And if you build this, you might, if you made everything correct or not, you maybe realize after a year or 2 only. Here, if it's done overnight, you realize overnight if it's good or not, right? Because then you can use it, consume the raw data entities for producing the targets. And then you immediately know if it's working for you or not. So faster time to delivery of your project and less risk, because you don't have to wait for 2 years, burning budget for 2 years until you find out what you've done is all not good. Let's say that. Can it scale? Flow.BI, I'll show you the tool in a second. Don't get disappointed or confused, because the user interface is relatively simple. I mean, really simple. It's not really complicated on purpose, because we said the AI should do the job, and we just influence the AI essentially, and that simplifies the user interface essentially. Now, don't get fooled by the application, because in the backend, we have a lot of MPP clusters. I can't remember the number. Like we have like 7, 8, 9, 10 MPP clusters running in parallel. And of those, 5 or 6 we have built by ourselves essentially, plus some other ones like Redis cache, that kind of stuff. But we built many MPP clusters essentially to process your to come up with the raw data vault. And it's a highly complicated solution, to be honest. It took us years and a lot of thinking to build or to design this and build this essentially. It's designed to analyze your source tables, derive your integrated business model from them, like the logical model for your raw data vault. And it doesn't matter how many tables you have. Everything is parallelized. If you have, let's say, 10,000 tables, we scale up the nodes, right? Everything's auto balanced. Everything can be scaled up. It doesn't matter how many tables you want to process. Everything's parallelized. And it's in the cloud. It scales in the cloud essentially. So there should be no limit on how many nodes you can order essentially for a short time. So it's possible to attach 10,000 source tables. Yeah, because if you have 10,000 source tables, I'm at least starting 10,000 MPP nodes to process your incoming source data sets and then come up with a raw data model essentially. Again, as I said, in my young years, I was distributing neural networks on MPP clusters to classify unstructured data. That's my initial research essentially. And then I came to Datavault and focused on Datavault for 10 years, or 10, 12 years essentially. But then it came back to me, maybe we do a circle here, right? And we're closing the circle now, combining both my topics here in Flow.BI now. Yeah, it's AI-driven modeling. So we have not one model that generates the raw data vault for you. There's a couple of models actually that essentially look at your data, profile your data, make these decisions essentially that need to be done. And what it does is Flow.BI restructures your source data sets by concept. I mean, that's what we do in Datavault anywhere, right? We have a hub customer and attach all the satellites from these different source systems to the hub customer. And the hub customer then integrates across the source systems. And so it's rearranged by concept actually. And that's what Flow.BI does. It looks at your data, identifies concepts, and then rearranges all your data around these concepts, comes up with the Datavault design. And then it also adds the relationships between the concepts, adds the descriptive data into satellites, and that's how the model grows essentially, step by step essentially. And the result is an integrated enterprise model as we teach it for years and more than a decade now. It's an integrated model across all your data sets. It's not just one model for one data source. It's a model that spans across all your data sets that you attach to Flow.BI. The hubs integrate across the source systems just like they should do essentially. Yeah, who am I? Just a quick one to close this up. My name is Michael Olschimke. I'm the co-author of Building a Scalable Data Warehouse, for those who don't know me. With Datavault 2.0, I wrote a couple of books or lots of articles, blog articles on the topic on Datavault. Trained more than 3,000 people on this topic. Implemented lots of projects, data platforms based on Datavault and other big data concepts, I would say. Real-time systems and so on, consult engineers up to C-level executives, up to board members of bigger corporations, how to leverage Datavault for the data strategy. And yes, I'm an expert for artificial intelligence as well, back from my old days. I've done all the projects. Once in a while, I had some good AI projects, but here the circle closes essentially. There's some research you can find from me in some journals where we published our work. That wouldn't help you to find out how Flow.BI works though, but it's another story. Cool. So let's do a live demo. Let's just show you how Flow.BI works. Flow.BI is a SaaS application in the cloud. So it runs in a web browser. There's a couple of design principles here behind the user interface. First of all, it's cloud native. Flow.BI was born in the cloud. I wouldn't say it's limited to the cloud, but at the moment it runs in the cloud only. Get in touch with us if that's not a possible solution for you. If you need to run this on premise, we can talk about that. But yeah, we have to talk about that. And then the premise is that all the user interface should run in a web browser, and we use a cloud API first approach, which means that every button we have here, every element here, we can script. Everything goes via a REST API, and you can script the heck out of it essentially. And we have two APIs. We have the REST API where you can insert, update, delete, let's say artifacts from the Flow.BI system, like data sources and so on. And we have a SQL API where you then can pull the logical model that we generated from it and then deliver it to your to Datavault Builder, for example. Let's say it's how Datavault Builder integrates with Flow.BI essentially via the SQL API. All right, so it's just some brief dashboard essentially, what's going on in the system. That's the test system here, so it's relatively small. We have the data sources here. I could show it to you. It's just the JDBC connector, how you would connect to a JDBC data source. Yeah, all the parameters. It's just JDBC connection. What we have though is we have both a data source where your data comes from and the meta source where your metadata comes from. So they could be separated. If you have, let's say, a data lake with Apache Drill, you have CSV files on some S3 bucket or HFS cluster or something. You only have data. There's CSV files. And the Apache Drill database would be empty. But if you do a select star from this one CSV file, you get data back. And Flow.BI doesn't really need metadata. What we need is data, actually. But we need metadata in the sense that we need to be able to identify what data you have. What are the entities? What are the columns and the data types? That's the minimum we need. But yes, the more you have, the better. So if you can also provide foreign keys and primary keys and column descriptions, we would use them to improve the quality of the generated model, but they're all optional. I don't rely on foreign keys that the data source provides to us. We rely on our own profiling, essentially. So the metadata connection helps you to provide additional or metadata that doesn't exist in the source, in your CSV files, in a drill, or in your data lake, and so on. All right, and then once you have that, you can then influence the system. You can, it's a bit slow here. 1 second, there you go. So what we do is we have a concept classifier that looks at your data set and identifies the concepts inside your data set. What's inside the tables, essentially? What are the customers, the products, and so on. And then, and there should be some, okay, bad example, okay. But what you do essentially, it gives you some recommendations, or it should give you recommendations here. And then, but you don't have to agree, so you can override this. So you can go for, let's say, the account table and say, you know what, this is not account, but this is, let's say, party. You just override this, free text field, done. You just override this, but by classifying the system, you give feedback to the system because the system is good at recognizing data sets or similar data sets it's already known. So for example, if you would attach a Salesforce data set to Flow.BI, it knows Salesforce. So it would recognize a good amount of source tables and recognize them and classify them. But if you attach, let's say, a SAP CRM system, it might fail. Now, first of all, if the structure is similar, it might actually succeed. If not, you can then classify these tables, and then it keeps learning. So the more data sets you attach, the more data sets other people attach, the more data sets it knows and keeps learning, essentially, and classifies these concepts later on. So it's a self-learner, but we do a moderated self-learning because I know you guys, people like to type in all kinds of nonsense, and we will essentially moderate the process, let's say. It could be a full self-learner, but it's not. So we moderate what the outcome is. But here you have one record per incoming table. And in the worst case, like in this case here, it failed for whatever reason, and we have to go through this list now and classify them. So that's 1,600 lines, I believe, 1,600, 1,700 rows, tables in the source data set. That doesn't take too much time. So we go through it and we're done. And also has essentially a classifier for reference data and for non-historized data, which will later lead to reference tables or reference hubs and reference satellites and non-historized links and non-historized satellites, right? Or dependent child links and so on. So these classifiers usually are there and classify data, and you can adjust them. We also have security rules, privacy rules, and rate of change rules. And in all honesty, that's a bit simplified at the moment. At the moment, we only do a regular expression on the metadata. So let's say if your source table contains name in the column pattern, let's say star name dot star, we say, you know what, all the attributes in our source data set where name is in the metadata in the name of the attribute, we classify those as personal, done. So super simple. But on the other hand, first of all, I know some enterprise tools where people buy these tools and that's all they can do for classifying the attributes into GDPR class, right? Person, non-person classes. And That's for us just an interface. As I said, we've wrapped up the MVP. We have the module already to classify your actual data for personal and non-personal data. It's hopefully we get this done by this year. We'll see, because we have prioritized it, right? And then what we will do is we will feed the regular expressions for you into this table, essentially, right? That's the idea. So it's consider this as an interface where you can again consume the results from the AI and then adjust the decisions essentially by the AI to get a better model essentially. And this is the input for your satellite splits later on. We don't do the satellite split. We just classify the attributes into one of these classes: security, privacy class, and rate of change class, and then leave it to Datavault Builder to do the actual satellite split. We're out of that. It's part of the physical model. We just do the logical part, and that means we classify these attributes and we're done. That's the simple part, right? Well, to some extent. Yeah, and that's more or less it. Once you've done that, you select the target where you want to produce the you want to send this to essentially. Hit the red button, that generates the instance, and then you get that's your Big Bang moment, no? Then you get the integrated model, and this 3D graph is just for the show, right? There's no real value of this. I mean, there's a tool where you can see what kind of entities in the center here, but other than that, it's just for we use it for debugging, but it's more or less for bragging how large your Datavault model becomes, right? And this is like I'm not sure how large this model here is, but I've seen models where we have produced thousands of entities in a raw Datavault. You want to have good naming conventions to deal with this, but again, that's what it is. So that's the future essentially what we produce here. There's some more options, but that's more or less the user interface. We do have a multi-tenant solution, so everything is here divided or separated by a client. So every customer gets its own tenant essentially. They have you have the capability of creating multiple tenants, so you can have your business hierarchy essentially inside Flow.BI. And you can have multiple instances. So, I mean, this is a test environment here, but typically you would have instances like enterprise platform, data platform or something, or one data platform for HR, one for compliance, different use cases for business cases, or maybe in a more data mesh environment, you could create one instance per data product you want to produce and attach the data source tables you need, maybe not thousands of tables, maybe only a few, 5, 6 tables for the instance, attach them. You can actually filter down the tables you want to attach to Flow.BI, by the way, and then generate a raw data from it, and then consume it in your data product with the business, or attach the business vault, the interface smart, and then you have your data product essentially to be used. So you can have thousands of instances. That's not a big deal, and they will all be processed in parallel essentially and lead to different separate raw data models essentially, logical models. And that's it, to be honest. There's some more buttons for options and so on, but they are boring, so let's skip them. Yeah, that's the idea of Flow.BI essentially. Well, what's the result? Just a final look before I hand over to Peter. What's the outcome? We have what we call a SQL API. Again, there's 2 APIs. The REST API, where you can control all the features in the user interface and script that essentially. Let's say you want to add 1,000 source data sets or data sources. I wouldn't do this manually, to be honest. I would use a Python script to add all these data sources to Flow.BI. You could do that. And then we have the SQL API, which is essentially based on Postgres, and that essentially delivers you the logical model and more. We have also a dashboard capability, as you saw initially. The information marks for those dashboards will be delivered there as well. But the interface automation, that's what we're looking for essentially. For example, there's an entity called hubs, and that gives you all the hubs, like just the entities, right? And the cool thing is everything is historized. So in Flow.BI, we have a repository in the backend, and this repository is essentially a data warehouse. A data warehouse, and if I would build a data warehouse, guess how I would build this? Using Datavault. So we have a raw data vault, a business vault, information marks inside the backend. Again, everything separated using row level security. So everything separated by a client and instance, and to some extent also sources. And when you connect to the system, you get an API key, and then that gives you access to those records that belong to your client and to the instances you have access to, essentially. That's a security feature. And because we use Datavault in the backend, we have all the changes. We keep all the changes. We keep all the changes of all the metadata that we ingest. When was a column added to your source system? When was it removed? How tables change over time, and so on. We have all the changes on the decisions we make. and all the changes on the target we produce. And the target we produce based on a snapshot date, as in data warehousing. This one is the version of the model that we produce. And yeah, that's the hubs. Then we have one for the business keys, for example. Very generic name. And then we have the key loads. Yeah, there you go. That actually defines from where the business key is being loaded. What is the business key from the source column essentially being used? Yeah, that's where these elements come from essentially. And then we have the links somewhere. There you go. The links here derived from your data model. There you go. We have the satellites, all kinds of satellites, including FET satellites and so on. And then we have the attributes, and those attributes essentially are inside the satellite, right? And here we define, come on. There you go. Okay. So here we define essentially, yeah, which status we have, what are the column names for the attributes, to which model version they belong, what's the logical data type that we define in Flow.BI, and we have to map this later to the data types inside Datavault Builder, for example. And then the privacy class, security class, change class. Here it's all the same because we didn't define any rules when we run this this model essentially. Comments, tags. Is it a descriptive attribute? Is it different? Special entity types, for example, have different tags essentially, but that's none of your business because that's being built by Datavault Builder. They consume it from here and essentially deliver it into their tool. And that's essentially where I should hand over to Peter because I'm not a tool expert for Datavault Builder. That's why Peter is here. So let me, yeah, hand over. Thanks.
Thank you a lot. And we need to say that there is a lot of common understanding as well. We have a simple interface. We're focused on the business value. We don't want to do manually all the technical stuff at the bottom. We have REST APIs for everything. We have a browser-based front end, so it really fits very well. We already deliver the Datavault Builder on-prem and in the cloud. So you can process then your data already on premises because still for certain clients that is still a very important point. So let's start now with my point. And I will focus on model-driven automation because this is what we've done always. And now, if this is somebody manually modeling your data model or Flow.BI is delivering us some information, for us, it doesn't matter. It matters for you, how reliant it is, how fast it is, do you find the right people to do it. But we believe still if we have the data model, we can bring data engineers and the business users together. They have means of communication, so there's more value than just automating the technical structures. You can use it for prioritization. And then out of this model, we generate in real time the physical implementation. And Michael was saying you need the patterns and you have it once and it's okay. Believe me, it's not that. We are constantly improving the patterns based on feedback, based on development in the database sector. So we're really optimizing for all the databases we support the physical structures constantly. And we can do that because the model stays quite stable as long as your business stays stable. And what many people forget if they start this kind of a project, it's not about one-time generating a code. You need to somehow set up your infrastructure to have the different environments with testing, production, development, sandboxing. You want to profile your data then while it's coming in. Even if already Flow.BI did some analysis, you still need to match in the day-to-day business sometimes if something changed. Then you have the modeling part that can be externalized now, as we have seen, code generation that we deliver in real time. Additionally, we generate documentation and data lineage, so you don't need to do that. And we offer as well the full functionality to deploy the changes between the environments. And we will see that's already very important of getting the different data models from Flow.BI, because Flow.BI doesn't generate one model and you're happy and you can't change anymore. You can integrate more and more sources as your company grows, as you maybe buy new entities, or if you want to integrate already existing entities in your data model, we need to be able to deploy changes. Then we offer REST APIs for testing. We have REST APIs for CI/CD, code versioning is happening here in Git. We have an operations module built in, so you don't need a separate scheduler. You can use it. We have REST APIs for that as well, but you don't have to. Data lineages in here as well covered, and you can reach high availability if this is relevant for you. As we don't have too much time, I skip a little bit this comparison part. how we compare to other tools. If you want to see how we compare to other tools, go to our webpage, please, and you will see there how the reports look like, and that we have very happy customers and long-term customers staying with the Datavault Builder. So how is the usual workflow in the Datavault Builder? We have the data model, then we go to the source systems, connect to the data, then we look at the data, we understand it, we create the loads, and then we can create a consumptions layer, model-based in the tool. And here's where Flow.BI comes in. And it's a little bit misleading that Michael is speaking only about the model, because they don't give us only the model to generate this here. They give us the information to connect to the data sources. They tell us which tables to stage. They tell us which data needs to be connected to the model to define the business keys. Based on that, we can do for the full historization in the satellites. And as we know as well how objects relate, then we can either manually or automatically, based on some of our rule sets, maybe based on the universal star schema, generate automatically consumption layers. So how does this look like? So we have seen that Flow.BI is offering us a SQL interface. So we take what we have, the Datavault Builder, and the Datavault Builder has a special model in it. We call it the Migration Vault. It's a model about the model. So it defines that we have hub entities, link entities, satellite entities. And now with our built-in ETL capabilities, we connect to Flow.BI, download the tables, and we have the possibility to connect here really with filtering. So we download only the latest model based on some metadata information from Flow.BI, load it here into our raw vault, and then on top of it, we have a business vault implementation that we maintain, and we generate so-called deployment packages. And we will see in a second why we are doing it this way. But this deployment package can be directly checked into Git, so it's optimized with many small files, prettified and everything, and it can be deployed. So how does this look like? I would say for this part, let's have a look into our live environment. So the meta model that we have, I have taken here only a very, very small piece of it. We have here like links, and I really reduced it only to binary links. We could have here as well links with many different connections. We have the hub as such. So this is a hub containing hub information. And now we need to map it to the Flow.BI information. So we have a built-in connector, and in that case, it is a Postgres connector connecting directly to the sources, downloading the meta information, and from there, we're going and loading it here into the raw vault. So here we can define what are the keys coming from Flow.BI or from any other metadata source, like if you would have already maybe some metadata dictionaries that you've created before and haven't integrated yet into Flow.BI, but mainly I would expect that you would probably integrate it on the Flow.BI level. Now, after that, we have our visual interface for creating output interfaces. And here we can really map the column names coming from Flow.BI to our expected Datavault Builder names, but this is something already that we deliver to our clients. So this is nothing that you need to do. So the only part that is there after you have connected your model, you can run the jobs, and it goes now, pulls down the newest model information, and will create a deployment package. This will take a few seconds. After that, that's what you don't see on the screen. I'm now importing the metadata model into my next environment. I will show you graphically in a second, but I have automated it for the first step. And this is how it looks like. Now we have all these entities coming directly from Flow.BI with the metadata information that we have here connected and already implemented. So this is not only a logical model, this is connected directly to the database. It created all the columns, all the tables and everything. And it doesn't stop there. You can as well go to staging. It already started here creating the Salesforce source system, and you can map more and more stuff like the loads, the satellites and everything. Just that it's better visible, I started only with 2 entities. Now you can see, yeah, but that's really complicated. So if you want to see the full process, you can go to our webpage, and I have created a real-time video in about 20 minutes, how we have connected this data to import hubs and links that you can imagine how this works and how it can be modified if you want to here as well customize some of the steps. Now, if we go back to the presentation, the issue is that one-time importing doesn't work that well. And we are not automating only, as I mentioned here, the core tables, the hubs, the links, and the satellites, but we get as well the information from Flow.BI about the data sources because they have it, they connected to them already. We get the information which tables to stage, we get the information which business key we need. So everything down to the raw vault with production-ready implementation is what we can automate. Additionally, on top of it, as we have REST APIs, you can set up some rules and generate directly a dimensional model or 3NF model, a universal star model, or completely flat table based on some of your rules. On top of it, you can manage here your business rules. That's where you will have company-specific configurations, and then we deliver this to the output. Now, the problem is, 1 week later, you updated your Flow.BI data model. What happens now? So we run the same pipeline. We have historization in our Datavault Builder, and we generate a new deployment package. So let's go back here to the Datavault Builder. And I have generated now for the latest snapshot the comparison. So I import it here and I do it visually. You could use the REST APIs, but so that we have here really the visual state. And it will now compare the new state against the existing state. And we will see what was added in the meantime. So between the two generations of the models, there was like the party element added. We can select that, the group element, and even some links maybe that we want to import. I select now just here the links that I want to import with it. And let's deploy that. And this means that like you would deploy as well in the Datavault Builder from development to test to production with a Git flow-based process, supporting sandboxing, supporting distributed development, you can use the same method to now step by step in an agile fashion import newer versions of your data model. So we can see now which hubs were created, like the hub party. So if we go back here to our data model and let's search for the party, we will see that this was now added. So let's go back to the presentation. So it means that we generate one package after the other. These packages can be checked into Git. So in Git, you really see which hubs, links, and whatever was added in which step. And at the end, we get some kind of extended model. And the cool thing is that it's two-way linked because we can store in the data catalog section of the Datavault Builder as well external IDs. That's something new that's now being released with version 8, but we're adding now a full functionality to capture as well the data owners and everything around the data that you need to operate it in Europe, like in a GDPR conform fashion. Now, what have we created in the meantime? We have staging created from the data. We can profile it. We can generate output interfaces. We can record then some specific rules in the Datavault Builder. At the same time, it generates you the master jobs, which are orchestrating the loads. There's a built-in scheduler. Documentation is created. And all of that happens in the moment I'm importing the data models. This is not like a disconnected process. The data lineage is available right away. And as well, like Flow.BI, we have a SQL-based interface to consume all this information, but as well always a REST API and the visual interface in the tool. We have a built-in Git client to check in then all our changes directly into Git. With all the changes being detected, we can work with branches, we can branch models, we can merge models, and it works out to show you then in the specific branches which objects were added in the last import. So if you go back here, it's really covering the full process through all the steps by receiving the metadata from Flow.BI. So it's not only the logical model, but as well a lot of information that we need for implementing the detailed loads for make it operational and deploy it into a production-ready data warehouse. And around it, we are adding as well the infrastructure automation by providing the application as Docker containers and all the modules that are necessary, not only to do development, but as well operations. So it's covering the full DevOps lifecycle. Let's go now to the questions. And some of them were answered already in text.
Yeah, used by time here. So
yeah.
There were a couple of questions regarding the data sources. If we have support Exasol, for example, as long as there's a JDBC driver for your data source, either a relational database or an application, there's like drivers from CData, for example, which we will which we already consume or deploy to access applications like SAP and Salesforce and Mailchimp and so on. As long as it's a JDBC driver, even from a third party, we can look at them and implement them. There's some easy ones, there are some more complicated ones, but that will be supported. But remember, Flow.BI is only concerned about the source data sets. I mean, if Datavault Builder is able to produce Exasol, so but it really depends on the Datavault Builder now to produce the target model. We only consume the data and come up with the data model, and then hand over the logical model over to Datavault Builder so they can produce the physical model then, right? So don't forget that. So I'm only concerned on my side here, on my Flow.BI side, I'm only concerned about the data sources of your data.
But the good answer is yes, we do support Exasol as source database to load data from, but as well as target database to generate our code on, like as well Oracle, SQL Server in all on-prem and in the cloud variants with Synapse, Google BigQuery, Snowflake, and Postgres. So we have a broad range of target systems, much more even for the source systems where we, as Michael was saying, support everything which has JDBC, but through our Trino implementation as well, NoSQL data sources like Parquet files or Kafka servers. We have some application-specific connectors like loading SAP data from the Theobald connector, or as well connecting to Python scripts through our gRPC connector where you can include all the classes. And we have our own Salesforce connector, so I can as well use the data that Michael is sending us over directly to load data.
Mm-hmm. There's a question from Will, or two questions. Let's start with the second one. Opens also hit the button. Opens also questions about change management and maintaining data history. Yeah, as I said, the Flow.BI repository. So I can only speak for Flow.BI here, but the Flow.BI repository is based on Datavault. So we capture all the changes to your metadata coming from the source, all the changes to the decisions we make, and all the changes to the resulting logical model essentially. So we have all these changes. So we could deliver this, and we will open up the repository step by step and give you more and more data from the repository to the point that we are also willing to give you access to our raw data vault. It's already secured. We just need to, I want to prove it more and test it more. But we can give you access to a raw level secured raw data vault, business vault, and all the information marks that are relevant for you. So you can actually build even more complicated solutions based on Flow.BI. That's from my side. Peter, you want to add something to the question?
Yes.
Or?
On our side is we assume always that you will not truncate your data vault and recreate it. So we generate based on the Git changes, the change scripts that's automatically built in the tool. You can do it manually with the visual interface or using a REST API. We're historizing as well the data, usually SCD type 2. We can as well do bitemporal satellites automatically if you have already external timelines delivered. So everything is covered, but it would be too short just to do more than just claiming that we support it. So if there are any specific questions, we're really happy to demo this kind of parts about change management, temporality, and keeping your data.
Mm-hmm. Another question, Willem. What about iterative development? Does the AI always generate a whole logic model? And when you want to change something? Yes. So if there's a change in the structure of the data sources, or if your data leads to a different decision, let's say what the business key should be, then you essentially Flow.BI will generate a new logical model whenever you hit the red button. Actually, if there's no change, well, the logical model will be the same, more or less. But it comes day by day, or even multiple times a day. Whenever you hit the red button, or even with a schedule, you can schedule the job actually in the long run. It will generate you and maintain you the model, but it's always the latest state. That's at least the feature for today. So I leave that for Datavault Builder at the moment to deal with these changes. But there will be also some upcoming features in Flow.BI to deal with this as well. I'm not there to talk about it yet, but we will deal with this. That you can actually absorb these changes much more easier. In a worst case, if Datavault Builder doesn't support this to consume these changes easier, in the worst case, I give a kickstart to process a couple of thousand tables, and then in the worst case, you have to ingest or perform the changes manually in the worst case. But that's not the future. The future looks different. Peter.
So in Datavault Builder, as we are having a Git flow-based workflow, we are calculating the changes for you. So we are happy that we get really the different states as Git is expecting it. And then based on this, I did now, as example, rollbacks. I went to the first version of the model, and the Datavault Builder translates now the changes between the different states in any direction. So you can do rollouts, rollbacks automatically. So you don't need, already with the Datavault Builder, you don't need to worry about this. And we're really happy that we're getting the full model, because then we can really decide on what the changes were since the last time.
I love the results you built with it, so it's really cool. There's one cool question here. So anonymous attendee, you're removing all the fun profiling and modeling. Yes, I'm apologies for that. But there's more. So I to be honest, I think I had more fun in. I mean, I had a lot of fun of building this, to be honest. That's number one. But then when I'm building a data warehouse, I also have a lot of fun in the business world and really adding business value to the platform. And that's in the business world, in the dashboards. That's what I would do and would go for. But it's good. I took a screenshot of this question. Actually, it's a really fun question. Any comments from your side, Peter?
No, that's good. And I think, but I think there will still be some fun left, because, you know, you look at the data and you look at much as possible, and somebody finds still a better way to destroy a process or change some data manually or whatever in some maintenance script. So there will be enough things to react on, but probably you will have more time to concentrating on all of this.
So last question here, I believe, from Wille again. Another topic is the amount of entities generated if you integrate, let's say, 10 source systems and you get 10,000 plus entities. How are developers supposed to validate and keep track of all the changes made, entities created in any reasonable time? You can't just trust the AI. I will fully agree. So how much time is actually saved? So first of all, inside Flow.BI, we have tests. So when we essentially generate the model, there's test cases that look at the consistency of the results we produce, and that's number one. And the design principle of Flow.BI is that we always generate what we call a valid model, because from a valid model you can always derive you can always derive any target model you want. For example, a star schema, snowflake schema, but also a better better data model. What we would do is in the business world. So I wouldn't touch the result from Flow.BI. I would then essentially adjust that in the business world in Datavault Builder, for example. So that's number one. So but I agree, don't trust the AI. But you can do these. I mean, you could validate this. It's just a lot of tests we have. I believe they are wrong. I need to double check this, to be honest. But they're in the 50s to 100 tests just on the model itself, right? Plus some other tests. Where we check all the, on a very generic basis, all the consistencies that we expect from the model, essentially. Yeah, that's remember what we teach essentially in the training. There's what we call a Jedi test. Hopefully George Lucas doesn't see this, where we essentially take the data in the raw data vault and try to recover or reconstruct the original deliveries one-to-one without losing any data and without artificially generating data. If you can prove that, and you can actually automate that, if you can prove to me that you have captured all data without losing data, without artificially generating data from the raw data vault, you at least have a valid model. You might not have the best model, but you have a valid model. And from this valid model, you can produce anything else, for example, a better data model. That's the basic idea, and that's the base principle of Flow.BI. So the goal was to produce a valid model, not even the best one, but that's my subject opinion, to be honest. Looking at the results, they are valid, but my expectation was not very high. It could be a bad but valid model, not a nice one, right? But if I look at the results, it's really in the upper half of between good and bad, essentially. So it's a valid model and really much better than expected from a quality standpoint, and much better than I expected it to be, essentially, right? So that's the idea.
I think my point of view on this is that we try, and many people in technology talk about agile development. And the problem is that usually the business users don't care about agility, but they care about the cost of delay. So how long does it take until they get the information? And it can be that in a first approach, it's not perfect, as Michael is saying, but they already get data. So if it takes them 7 months or 12 months until they receive the data, they already lost so much business value by not saving costs or by not gaining revenue, that it was really, really expensive. So here we try to get them the data with the raw vault approach as fast as possible. It will not be perfect. They need to validate it. So now they can consume the parts that are relevant to them. They need to cross-check it against their source applications. They need to do their validation still, and only then they can use the data. But already it's there, and the iterations are through automation and standardization and AI support much, much faster to shorten this kind of life cycle things.
And remember, it's not about the number of entities, actually, it's about the complexity. When you know how to test a hub, you can test 1,000 hubs. So we automate these jobs, right? So if you would build a test platform for the logical model of Flow.BI, for example, and again, we have that already. But if you would build this by yourself, you only have to test a hub once and then 1,000 times. You only have to test a link once and then 1,000 times, right? It's queries against the logical model, essentially, to test the consistency and the correctness, essentially. And same is true for the Jetta test. You build this once for all the 1,000 tables, essentially, but you don't have to build 1,000 different tests, essentially, right? So those tests actually scale, and you can apply them on small models and large models, doesn't matter.
Yeah, I wasn't. I understand. I agree with you, but I was as well answering a little bit other aspect. Does the data make sense that we deliver?
Yeah, yeah.
Because that's the different. That
That
it's
is a different one,
technically
right?
correct. That is our business. Yes, we have a lot of regression tests there and stuff like that. But yes, it still needs to make sense. And sometimes what the source systems deliver as data is not really meaningful to the business user.
And here you see the different shift in the focus, right? My focus is more on the consistency of the model and delivering the right raw data. And your focus is really on the second part, making sense of the raw data, which is dirty and whatever, there's missing data and so on, and applying business logic and producing the right results, what the user expects downstream. And that's, to be honest, the business value. Yeah, that's my opinion. Okay, so one question here. How will Flow.BI cope with the same business key that has different representations in various sources, like numeral 1234, string 1234, string 001234? All right, so first of all, we turn the business keys into strings only. That's number one. I believe, yes, yes. I'm not 100% sure, to be honest. I could double check that, but that's number one, I believe. And then in the worst case, like the string 001234, if you have those strings, you might end up in a hub where you have both business keys. Or let's say, yeah, in this case, you might end up in a hub where you have two business keys in there, 1234, converted from a numeral and from integer value and from the string, so it's only one row. And then you have the other row in the hub, 001234. I agree with you, it's not the best choice. But we can solve this later with a business rule that's in the business world, essentially. So having a same as link that indicates those strings are the same. That's the worst case. It's still, and here's the thing, it's still a valid raw data vault, right? It's just not as efficient, but that's what we have to deal with sometimes. Yeah, so if in the best case you prepare the data a bit. So if you know it's a business key, you would essentially trim those leading zeros off, because Flow.BI doesn't handle this at the moment. We might think about handling it, but yeah, at the moment we don't do that, actually, to be honest.
Okay.
But yeah, having two business keys in the hub, same as link on top, that's done or defined in Datavault Builder. But you also have a more common problem is actually when you have two different business keys identifying the same business objects, also leading to two different business key entries, and you need to add some same as links in the business vault. That's what it is. Yep.
Okay, so our point of view is very similar. We believe that we need to turn everything into strings, so we do that anyway when then you're loading data. The problem is you need to differentiate between source systems where it makes a difference or not. I give you an example. In SQL Server, you can write your name, and this is your business key, and write your name and add a space. SQL Server usually don't differentiate, but still, it stores it at two different entries. So you could create links for two different entries. Even the join engine naturally is not evaluating it. But now if you remove just the spaces at the end of your term, you now put the links of two entries, which are really two entries, together. And we had this kind of cases. So what we do, we process everything as it is, but we give you the possibility while staging the data to put in a trim rule if you know that there can't be a difference. I give you example, DB2, if you have at the end a space, it's probably just a fixed char character field, and it can't make a difference. You can't store there a space. It doesn't exist. It doesn't make a difference. And there it's very safe to trim. So it really depends on what your data means. But the worst case, just as last example, we had the SAP data, and the only difference in the business key was that one had lowercase x in it, and the other one had the uppercase x in it, and there were two distinct entries in SAP having two different tracking numbers for shipments.
And here's the thing, Flow.BI does not kill your job, to be honest. You still have to feed the data from the sources into Flow.BI to be analyzed. And this could be one option where you could optimize the data a bit to make it easier for Flow.BI to understand your data or identify the same business key across systems, essentially, right? But if you don't do it, the idea was, if you don't want to do all these optimizations, if you just want to attach some source system to Flow.BI, hit the red button, don't care about anything. It will produce a valid model. It's just that when you start influencing Flow.BI in producing a better model, let's say, you then get a better raw data model, essentially, and maybe easier model to process downstream. That's the basic idea. So yeah, if you don't do anything here, you would end up with two business keys in a hub, and I double check that it's always a varchar by default, which you would also customize though. All right. So I don't see any other questions, and it's good timing here. So Peter, thanks for having me. I believe we're done.
Thank you as well. It was a great pleasure and great honor. And thank you for everybody that joined our session here and for asking questions. It was a pleasure. And if anybody wants to see more, we have on our webpage the full video of generating this metadata flow. You can book a demo with us or get even the trial with Michael. So feel free to contact us and see more of what you're interested in. Thank you a lot.
Thank you, guys.
Bye.